Lisa Gunner. I'm the Director of Product Management for Advanced Technology, and today I want to share with you our experience about live production in the cloud. First, I will introduce you to what elastic distributed production is, and then we will talk about Blizzard's master control production and how the impact of COVID changed how Blizzard's operations have been done and how they eventually ended up doing an elastic distributed production. At the end, I will also share our lessons learned with these new technologies that are around. So this here, that looks, I think, really familiar to most of you. This is how we do live production for a very long time. We send OB trucks and people and equipment to an event, and then, of course, in our broadcast center, we also have probably the same amount of people, of equipment, and so on at there. So what if then you even need to scale this up? So if you need to do 3 events in parallel. And here is like a clear illustration of that scale issue that I just alluded to. If you need to produce 3 events, I need 3 times as many people and equipment on site. This is typically a production for, say, a sports league where you need to produce several matches concurrently. And then you always need to provision for your worst case scenario. However, some of these matches may not be airing at the same time. So some of them are even overlapping, which will require you to even have more of your equipment and your hardware at home. Yes, of course, there are always ways to improve this utilization, but you still need hardware for that game day. So how could you fix this utilization issue? Well, what if you had access to any of these broadcast functions when and where you want them, and actually to build something without handling always the worst case scenario? So all of these functions, and here I'm not going to show all of them, are typically embedded in products that you deploy at your facility. They may be running on dedicated hardware, on servers, or even modular frames. So what if you could deploy these functions on demand and in the cloud? But however, this have never been really simple. It is that, of course, elastic compute is hard because especially that flexibility and that elasticity does impact us very hard, especially look into live production. So for OTT and streaming, we've already been quite ahead, and we're adapting live already. But then linear playout, that is something which just started. But then when we look into live production, the challenges are actually really big. So why is it so hard for doing elastic compute? Well, some of these answers, that is typically what we've been hearing from customers, like a very low latency, and that is not really a broadcast case solution. We really don't trust the cloud, and it doesn't scale so well. But how can we fix this? And this is what I want to talk with you about in the next chapter of this presentation. So let's have a look at Blizzard. Who is Blizzard actually? Division of Activision Blizzard is a premier developer and publisher of entertainment software renowned for creating some of the industry's most critically acclaimed games. So Blizzard Entertainment's track record includes 14 #1 selling games and multiple Game of Year awards. And as you know, all of esports are just becoming a major hype. So there are 2 conferences in the Overwatch League, which is their major game at the moment. And these 2 conferences are divided into 4 divisions. So for their 2020 plan, they had about 28 regular season games. There was just a normal home and away format, and then a production managed by a local team that was going there. So it's geo agnostic, there are various different places. They wanted to aggregate video in the cloud and then pull up a web-based interface. So what are the Blizzard's requirements when they came to us about 1.5 years ago? For them, it was very important to spin applications up and down quickly, have an intuitive user interface where you can interact and where everybody can create the look and feel how you really want to work on it as an operator. Have it controllable from everywhere so that you can actually sit at home like I do right now and produce from there, and have a managed latency for a responsive operator control and not what you usually occur when you're going and running remote productions. So efficient way to handle that also was to have regional branding and advertisement opportunities in there, and to have really that ability to experiment around these things. And that was where we wanted to build an efficient way together with Blizzard, which brought us to the first production we did. That was the home and away workflow. How they did it, that was pre-COVID. So they had a home team at at 2 venues, and there was talent there, like a normal sports production that you would do. And then they also had their pre-game, halftime, and post-game show, which was done in Southern California. And all of that was going into the master control and transmission, and then eventually played out on YouTube in a number of language feeds and a number of brandings. So as said, it has been done in a completely normal venue truck production and in a traditional way, how it was deployed there. But one difference, which is there from traditional sports, these are virtual cameras. So the virtual cameras, which are actually in the game, these were ISO feeds in the production, and they came into the camera control, and they are all managed by the observers. So the observers are more or less like our shaders in a normal production. These are like 2 to 4 people, but they're also the virtual cameraman to actually run the game engine, and they use in-game controls to provide these ISO feeds generated by the computers, so that we can see what is actually happening within the games from various viewpoints. And they're really intimately familiar with the strategies in the game. So these people are usually co-located, and they were co-located in the pre-COVID model. But here, as you see, everybody, which we can't imagine anymore right now, in the same room. But then, the thing was, what we did, getting these 2 feeds in from the venues, and then running a switcher, running multi-views, INO, routing, and having clip players, HTML5 renders, and so on, to make a production possible with English and with regional feeds that are then distributed in YouTube. So how does this look like, and what is actually that whole thing about? So this is where I want to introduce you to Ampp. So this is actually what is the intuitive user interface. So some of the applications, for example, the master control switching, multi-viewing, low latency monitoring, and routing. And all of these different applications allow to, in the beginning, do simple productions, doing switching. You can bring on keys and so on to really make what you are used to from a master control operation. There were interstitial playbacks via an API integration of third-party with reality check, and HTML5 graphics were coming directly on display with a singular live here. And how that actually looked like from an operator interface is what you can see here. So you see him really working on the master control. He sees the program feed out there. He has some clip players down there, and then also has his multi-view to really see all of the feeds that are coming in and out. So this is really no physical infrastructure, that is work from the real home. So you only also pay for what you use, and all monitoring of the local program distribution processes take place entirely in the cloud. So when you put together an Ampp production, you pick from a list of tools for what you need in your broadcast, and that's like really amazing, because you just say, oh, I want to create this kind of workflow today, and then on the next day I want to do something completely different. It is as easy as I just described it. But then what happened? So COVID hit, right? It hit us all. So this is where Blizzard needed to rethink how they can actually stay on air, how they can do and produce their games every weekend. And that was, what I just described, right? And just to recap the master control workflow, so 2 teams, having a virtual MCR and a virtual MCR operator. So he was, he was sitting at home, so he could do that. But then, of course, with COVID, things were not that simple. So also in the beginning, with COVID, the whole question was, so how can we produce that without any production facilities, mobile or otherwise, at the locations? And how could they actually stay on air? And this is now the path where we work together with Blizzard to make this happen. So what we actually did was we started, to get these observer stations also on air. So they got screen captures, they got contribution, they got low latency video to be able, from 4 locations, everybody was sitting at home, to run a low latency live feed into the cloud, yeah, and these were in, and there was a sub switch which was created. Then we had the two casters, which are like the commentators, which were also sitting at home, getting in the contribution, and then running into the main program. And this together with some of the analysts, which were also, you know, of course at that point, sitting at home, weren't pre-switched, and you know, you could create like actually 3 full programs, and all of these were then fed into the part that you already know, where we had the master control production. These were 30 people of staff, all making all their decisions based on this low latency. Some of the stuff were running computers in their house, some of the presenters were using OBS and a webcam, you know, to stream into the cloud, but actual computers who process the content are all with the customer, so they were all owned by Blizzard. And the technical director, producer, Envision mixer, graphics at home, and presenters are all at their home in their houses. So 30 people, and all of them, you know, graphics, as I mentioned, done with Singular, so the matches were coming in directly from the computers, and 4 virtual cameras in the game which were switching, and time aligned, of course, across the whole production. And all of that was the Ampp low latency contribution, and this is a collection of existing IETF and SMPTE standards used with RISC ARQ protection to minimize latency of contribution quality feeds. So that is really where I think that is you know, a tremendous thing. And of course, like this emergencies that we had during COVID really made such a speed on how we run workflows today. Just here you see some of the pictures, thanks to Blizzard, they shared those with us, like how graphics control and how it really looked like in their home. I think we all know these kind of setups nowadays where we have video equipment and everything, but here this was a real full live production. They were using intercoms from all the locations, so it was a simple thing, having the communication done. So how was this really made possible? So let's talk about this a bit, because this is, you know, a full thing now about how Ampp is done and how Ampp is built. So this is a microservices-based approach. Yeah? So we have individual user interfaces for every application that is running in Ampp, and we allow to distribute these user interfaces to each operator with only the tools that they need. So you don't need to have like everything with a monolithic Ampp, but you can really pick and choose what you would want to have. And that was how Blizzard built their production. And that was, you know, a quite easy learning curve, because you can just pick and choose. You don't need to explain everything of an application, but can actually trim it down to what is needed for that certain position in the production process. We added a rudimentary audio mix capability because, as you remember, master control is not usually where we have all that full audio mix capabilities at first shot, but that was during COVID how we can speed up things, how we added this functionality so they could actually stay on air. We used more mix effects to create 2, 3, and 4 box looks so that they can bring in their casters, that it looks really simply like a full like a full live production as you're used to, and then apply the core technologies which are inherent to Ampp, and you see them on the right side, which is how we really focused on solving the intelligent timing, for example, and intelligent connection, so that you can always stay time aligned between all the different systems, having identity services which allow you to have everything within your account, and so that you have all these access that you need. So an example here, as I mentioned, intelligent media timing that allows to entirely frame accurately align sources and manage timing to give operators instantaneous responsiveness. Yeah, they have a coherent experience. So if you press a button, that literally happens in this moment when you do that, and not just you press and then you wait. So everything happens instant, and this is one of the core technologies which are inherent in Ampp. So here is a system visualization, what we call our system dashboard of Blizzard systems. So that comes with it. Everybody that has Ampp can build his own dashboard and see really how does my workflow look like, right? It's not the other way around, but you can build your workflow. You see like, oh, this is where actually the thing happens, where is there possibly something we could add, and so on. So here you see that, and here of course, as you see, source alignment is important because we have all different locations. It's distributed, it's from everywhere. So how do the feeds get into the cloud and at what bitrate? So we did like SRT and I think about like 10 to 15 megabits, and they stream to their final playout about like 20 megabits, right? So we work on proxies when you're at the operator, but then for the final you have just a full 20 megabit stream that you can bring completely on air. So here you see the different parts. Yeah? So the observer subswitch, for example, that was done for the inside camera people. So all of them at this moment sitting at home, not anymore in that same room as you saw in the beginning. Then we had the casters, which are the commentators commenting on the things that were there, coming in from both the program, but also from, of course, the observers, which were inside the game. And then we had the main PCR bringing all these signals together, and of course the analysts show were the studio. Yeah. So but these guys were also at home, so everybody needed to get it together, and then having the MCR play out at the end where they produced 4 different language feeds, which were then distributed with also different advertisement and localized and regionalized parts that they added to their program. So just to show here how important that source alignment really is, it is that there are feeds coming from all over the place. Yeah, they're coming from different locations, from different systems where they were spanned across the whole US, and here really bringing this together. So the importance of having a delay module, and for example, so that because sometimes you're even too quick, right, because some parts aren't there, but the importance of that delay module shows is here also, that you can see in this picture, because what was here is that we wanted to have actually everything aligned, because with 60 and with OBS contribution we had almost like a 10 seconds delay in the whole production, but then all the other sources, they were faster. So you want to have everything, of course, aligned, and you want to manage all this latency across your system and have all of that entirely under your control. And this is what is possible to do with Ampp, so that you can bring in from either Southern California or from Oregon, or from the cloud was hosted in AWS US West, which is north of Oregon, bringing all of these different signals under control and time align them. So this is, where they aligned the delay. So you have the delay to time align with your caster feeds, and then also having other casters, which were somewhere completely else, completely different location, or coming out of a toolbox, and all of this just to bring it under control. And Ampp gives you this overall possibilities to align this and to make it a really simple workflow. So what are the lessons learned? I think what we realize is that there are compelling use cases for cloud-based master control and production, and that now is really the time to explore those and work on those more than ever before in the history. Then for us, it was very, very important to invest in a lot of robust logging and monitoring, because once you're remote, it is not so simple just to get on somewhere and getting somewhere there. So you really need to have access to all the remote systems and get all the information that you need to. We changed our entire process to DevOps, so that we have really a very close relationship between our operations and between development, so we can feed back all of that continuously and improve the system on all the time. Yeah. So automation, of course, continues to be critical. So automating processes within this, making it really simple for all the operators, and making broadcast and live production becoming just a very simple thing that you can use very quickly without a long learning curve. And for us, most important, really the value of deep partnership and the attitude to explore new ways of production. And this will determine, I think, for all of us, the speed of adaptation for being live in the cloud. Thank you.